Hello, and welcome to your weekly webinar number 18 with me, Michael Floyd. I am your mentor and your mentee. You learn as much from me as I learn from you. Now, just go over some things, the same things we go over every time. Still the introduction forms, the same 5 have not filled the introduction forms. If you can get back with me and fill them out, that'll be perfect. That'll be great. As I said before, as data scientists, we can understand the importance of having a full data set in order to work with and make accurate predictions and metrics with those full and accurate data sets. So, hopefully you get back to me and let me know soon. So, and 7 out of 12 of you have completed. I believe it's 6 out of 12 have completed the second project. So more people have completed the second project. Fantastic. I know Sine is well on his way to completing his third project. I'm hoping we all get the ball going. We have the ones who did not complete the first project. Look, it might be late, so you might not have enough time to do all 3, but at least putting forth an effort and completing even the first project, right, will show miracles, and you can also put it on your LinkedIn profile, on your resume. And like I say every time, the money is already spent. So if we can occupy our time to try to complete these projects as soon as possible, that would be great. I said previously 30 minutes in the morning, 30 at night, but we are at the last seconds. So wind down the clock. So of 2 hours, in the morning, 2 hours at night, even more. Try to work full-time overtime to complete this before the deadline is there. And every time you do something, just write on Slack if you're having any problems. If you finished anything in the lessons that you may feel like some people may need help or guidance in, just write that in Slack. We have 3 students, A, B, and C. With student A not having any responsibilities, none of us fall in that category. But as far as student B and C, I think a lot of people have fell into the category of student C, right? You have the job and a family, but it seems like you stay consistent with your schedule instead of interrupting that job work time or that family time in order to get things done. And we have some of you that are student B, and of course, student B is the one who inconveniences everybody else. So on to today's topic. Today's topic will be Hadoop, Hive, and Spark. And what I will do is I'll begin sharing my screen right now because I want to show you how to put up the MapReduce EMR cluster on Amazon, but that takes a little while, so we're going to do it now, and I'm going to share my screen before I start explaining a little bit about Hadoop. Okay. So I believe the screen is shared. So what we're going to do is we're going to go to Elastic MapReduce. You see I just terminated the cluster, but I want to go to the clusters and I want to create a cluster. Those are previously terminated clusters. So I'm going to name this cluster Data Science Nanodegree, DSND. And what a cluster is a so it's loading. Give it some time for applications to load. But what a cluster is a series of instances that are all connected together. So what we're going to do is we're going to do M4 large, and we're going to have 3 connected, 1 master that we're going to be running all of the functionality and placing the files in order to then place them into Hadoop. And we're going to have 2 core nodes. Now, these core nodes, you don't just have 2, you can have multiple, a lot more than 2. But just for the sake of this small example, we're just going to start off with one master and 2 core nodes. And this demo is going to be using Spark. And so let me explain a little bit about Hadoop and the EC2 key pair. So this is exactly like what you would see in a EC2 instance. So you need a EC2 key pair. And remember before in the previous webinar, learning how to create and use the EC2 instance, we had the data science standard degree. I know I had a couple of other key pairs just for my using different things. So I'm going to create this cluster. And that cluster is creating. And while it's creating, I can explain some things about Hadoop. So, what is Hadoop? So, pretty much what Hadoop allows you to do is it allows you to distribute files across different computers, or in this case, the 2 core nodes. And why is that important? For one, if you have the files distributed across different nodes, and of course these different nodes are not all different in their creation of the different blocks of files, but the blocks of files represented multiple times in multiple different core nodes. If you have and why is that important is because if you lose information or one of the nodes fails, then you can then the other nodes can always back up that node, and you can then keep on proceeding. And the reason why this is needed is primarily due to big data. And Hadoop is needed because 90% of the world's data was generated within the last few years, which is pretty extraordinary to think about. And I read somewhere, I believe it was actually in this little guide right here. I'm going to send you the link to this guide, but actually a cool insight is until the beginning of time. From the beginning of time until 2003, there was 5 billion gigabytes of data created, and just the amount of data that was created in every 2 days in 2011 is the same amount as the 5 billion gigabytes. And in 2013, every 10 minutes has those 5 billion gigabytes. So if you can imagine, being able to compute and process big data when necessary, is very important. And the cluster is configuring, starting. That is good. Going to Control C, and remember, whenever we are trying to access the EC2 instance or the cluster in this instance, which is a group of EC2 instances, what we're going to be doing is we're going to be using PuTTY, and PuTTY is going to allow us to access that instance. And just a little more about big data while that is loading. So the reason why we say the name big data or talk about big data is because remember the data science standard degree. So I already have my that's the good thing about creating this. I already have it loaded. As far as the data science standard degree, I have the different terminals that are needed and the PuTTY key that is needed already in this, already saved as far as a session. So all I have to do now is just, delete the IP address that was there currently and place the, the new IP address. We're going to wait for it to load. And also we're going to be using WinSCP to transfer files, make it easier to transfer files. Okay, couldn't find it. Here it is. WinSCP. So yeah, big data, like I was saying about big data. Big data means using regular techniques on a regular computer would not be possible in order to do the computations that are necessary when you are attempting. Move this over. So when you are attempting to do computations and the data is so large that your computer would even crash, because the attempt to process it, that is big data. And Hadoop and Google solved this problem by using a MapReduce algorithm, and I will talk about that and I will show you something about that in a second. I'm just going to paste this and save this. So I also created one for data science and degree. So everything's already saved as far as the putty key. Just have to change the username, which our username in this case. So for the cluster, the username is Hadoop. Save, and we can log in once this is completed. It's running. Okay, so it's running. So we can log in. Fantastic. And of course, it's going to ask us the question, do you trust the source where this is coming from? And just click on yes. And so now we are logged in. Fantastic. Okay. Just some things we want to drag in here. Okay, like I said before, we're going to be using some documents. So a couple examples with Spark. So we're going to be dragging this book file. So we're going to be, part of the book, and I'm going to show you how some cool things we could do with that. As far as it's going to be a Python function, and we're going to need this 1800 CSV as well, and we're going to need this information, and this is movie ratings from a million different movies, a million different ratings from. It could be a couple of different movies from different people. So while that's loading, we go to this, and so Google used an algorithm called MapReduce to solve the problem of big data, of course. And so what you don't see is one just big system or one computer that has a whole bunch of hard drive and RAM space just solving or just doing one function. What you would have is you would have a centralized system. It's like we have our master node, and this node then allocates different places. It distributes the files to these other hardware systems, and these hardware systems then perform functions, and then these functions, and then once you call it back, it integrates into what you were looking for, or to the algorithm. So that is how the Hadoop works as far as distributed file system. You can have more than 2 core nodes. We only have 2 core nodes. But what it does is it distributes the files among those 2 core nodes. When you're calling a function using Spark, which what we're going to be doing in this case, it then Spark then has commands that it lays, and then through those commands and through its distribution of the files, it will then be able to better allocate the memory, and of course do big data problems. So yes, let's check the WinXP. So we're at 23%. Okay, and just something to show you while that's loading is, while I was at Washington University getting my master's, I actually came across a big data problem, and the problem, what the goal of what I need to do is to um, combine different data sets that were sampled in a complex manner, and they're taken from different the U.S. Census Bureau, and the U.S. Census Bureau does multiple different sub sampling. So that, they had a medical expenditures panel, and to find the expenditures or the different metrics on expenditures for families, for individuals, and they don't sample in the similar manner which you would random sample, because if you have 300 million, 400 million as the population, and you attempt to random sample, then you would need 3 million, 4 million, possibly 40 million. So what the great technique is to do complex sampling designs. So you stratify, you cluster, and you sample smaller subsamples of a population larger than you would sample a sample of the population that is well documented, or is the majority. So getting the minority and then placing a weight upon minority as far as you have sampled. But the problem is the analysis for complex sampling is very complex. So and it costs it's a lot of computational time and computational energy spent for computers, especially when I had to combine multiple years of was deriving from the medical expenditures panel data set. And so my computer continuously crashed and crashed and crashed. And I developed an algorithm similar to what you see from the Amazon. I didn't know about Amazon Web Services at the time, but I was reading about different algorithms that are tailored towards when you cannot successfully complete it on one machine. And so in order to get the confidence intervals I needed to do the bootstrap method, because we want a bootstrapping method as far as our as far as what my supervisor wanted. So in order to actually do that, I had to base a method that resamples, but does not resample in a manner that you would normally resample bootstrap. Actually places them into best sample those find the bootstrap. So in other words, what you're doing is taking subsamples, these subsamples on different machines, and then those different machines are then resampling these small pieces to combine all that information together and come up with the overall exactly the same as what you would expect of just doing it by itself. So the results are similar. Explain a little bit about that while everything is loading. I will close that, and it's still loading. So when we get loaded, I believe we want to save this. Make sure this is yes. Log in. Name of the IP address. So you can already have the login name there, but I like to just log in as Hadoop. So now what you see, fantastic. You see it's elastic map reduce. Everything's up. And what we need to do now, because we have the files, if I ls, you see the files right here, right? And the file part for the ratings data because it's not completely there. But it is not wanting to have it in the local storage. What you want to place it in is in the Hadoop distributed file system. So Hadoop will distribute the files in blocks of size 128 megabytes and or 64 megabytes, which is the default. So all you do is just call HDFS and distributed file system and put, and you have 1800.csv, and then where you want to put that is 1800.csv, which is going to place it automatically in the user/Hadoop/ section part of where the distributed file system is stored. And Spark will know automatically because that's the default place where it's going to search for files. So, putting this in a default place, and also I'm going to do the same thing for the book.txt. We have book.txt, and just put this in book.txt. And what the 1800.csv file is the 1800.csv file is a list of, it's a CSV file of weather recordings that were recorded in the year 1800 in different parts of the globe, and it has the highest temperature and the lowest temperature for each day in different parts of the globe. And the WinSCP is finished, so we can move, just put ls, and now you see the ratings is not file part, it's there completely. So now we can move the movies.dat. And I believe I probably could have just pressed star and just moved everything there. But now that we are almost done, just ratings.dat and ratings.dat. And the last file would be the users. So all we're doing now is just taking this from the regular file system and putting it into Hadoop file system. All right, fantastic. So now that those files are there, we can start running some Spark code because Spark is it's already there as far as downloaded. So it's PySpark. So I have to call. We're going to wait for that to load. Fantastic. So that has now loaded. And so now we can start writing code. Okay. Let's start with the 1800 CSV. So what our final result is going to be is we're going to want the minimum temperature For the day. Okay, so let's start writing the code. We're going to have here we go. Okay, so RDD, that's going to be our resilient distributed data set, and that is pretty much the set that the data set that is created when you create a Spark content file and sc.text file, and we're going to be calling 1800.csv. So now Spark knows that that's the distributed data set we're going to be working with is the Spark content.text file. Okay, and from here, let's create a function. So definition of parse line. We're going to be calling line. Okay, and the fields in the line, we're going to split the fields by comma. This is a CSV file. So now that we have the different fields in the line, okay, parse line. Perhaps I indent. Yes, I do have to indent. So fields, like I was doing before, line dot split and split by comma. Well, by comma. And what else? Since we only need the ID of the station and the entry of the station, we're going to just be using the we're just going to grab the ID, the entry from the station, also the temperature, right? So the temperature in this CSV file is stored as tenths of Celsius. We're going to convert that into Fahrenheit, and just to show how to convert to Fahrenheit. So we're going to have to make this a float. The fields, the third text in the field is actually the temperature, and we're going to be multiplying that by 0.1, which is the temps, and then we're going to do the conversions for the Fahrenheit, from Celsius to Fahrenheit. So times 9 divided by 5.0. Make sure everything is floats, so everything goes correctly. And then plus 32.0. I don't think you need to have to make it 0.0, but the temperature. So we have the temperature. And so now what we're going to be returning is the station ID, the entry type. So the entries for the station are maximum and minimum. So each station does maximum and minimum. So we're going to return the entry type along the station, and later, using the help of Spark, we're going to decide which one's maximum or minimum, and then we're going to be using that in to filter the data. So return fields 0, fields number 2, and we're going to be needing the temperature. Okay. And that is it for that function. So, and now with the resilient distributed data set, we're going to be now calling the map function. So the map function, maps each line and then provides a parameter for the line. So similar to like calling a lambda function. So we're going to call this parsed lines and make this equal to the resilient distributed data set dot map. And then we're going to use our parse line function that we just created above. So that's going to do is going to take each line from the resilient distributed data set and then split the line and change the temperature and return the fields. So the station, the minimum or maximum, and the temperature. So that's what it's going to do as far as the punch line function. And Spark does not do any programming, or it does not do any computations until an action is called. And map is not an action. Map is just telling you exactly what functions need to occur. And we have not called an action yet, so nothing's happening. So we're going to be doing more things with the filter, remember? So minimum temps. So we want to filter the parse lines. And now because this is more simple, we can just use a lambda function. Of course, we can use a definition again similar, but the creating functions like this are come more in handy when you have multiple steps you want to do within one part. And we just have lambda x such that so only return if T min, which is the temperature min, is in x1. And so, it's only going to return if T min is in x1. Where does x1? X1, remember, we're returning 3 fields here. This is his first field. It's the 0, x0, x1, x2. So T min, or the minimum temperature. So this is a minimum temperature field, then we're going to be returning it. And this is still not a action. It's just a filtering. And so now we have station temps. And now we're going to be creating a key value pair. So now we have the min temps that we had before. And we're going to be mapping and using a lambda function x such that we have x0 and x2. Okay. And okay, close it. Gotta close that. So what we now just did is we now we had 3 values before. Now we just have 2 values. So now we have a key value pair we can work with. And we're going to be calling another function. It's going to be reduced by key. So with key value pairs, Spark has different things you can do with key value pairs, such as the reduced by key. You can call a function and then can reduce the whole data set into how many keys are necessary. So show you this. Um, so we're going to be using this min temps, making this min temps and equal to station temps dot reduce by key, and calling the lambda function again. And x and y in this case are two values inside of our data set. So for each value of x and y, it's going to keep repeating this. So each value of x and y, what it's going to return is going to return the minimum of x and y. So now for the whole data set, and we call it reduce by key because now this only looks at the values, right? So this only looks at the values that are in the key value pair, and that saves us some computational time. So just looking at the values that are in the key value pair, which is the x2, which is the temperature, is going to take the minimum temperature. So find the minimum temperature that is within the entire data set. So the coldest temperature in 1800. And then in order to call the action, all to do is press results equals the min temps. So our final data set dot collect. And once I call that, then it's going to begin, the process. So now the process is started where, MapReduce is telling it's finished already. Very quick. So MapReduce was pretty much telling MapReduce was, allocating exactly what functions and how these functions would be able to, and how these functions would be able to, better analyze the data and do these steps that we asked of it to do. So, we have that, and we only have two, as you saw. It said 0, out of 2. So only 2 were being able to be used. 2 nodes that we have. So print result 0. So it's going to print the result that we have plus, and just put a little tab in there. And then we're going to format to only have 2 decimal places. So, and it's going to be the format. And press enter twice. Unknown code F for object type string. So place the tab, and then dot 2F. I don't think I need this F. Okay. So let's try to print result 0, then plus tab, and then plus result 1. All right. Wait, I have a, okay. So I have an unexpected indent. Okay, so the indent is gone. So for result, in result, so I believe it's going to have to do result 0, 0. There's only one result. So result 0, 0 is just the first result. And result 0, 1. Okay, so I see what I did wrong. I have results right here, and it should have been results. So see what I did wrong before, but this should still work. So for result, in results, print the result. Okay, so there's multiple results. So that's the coldest temperatures in the globe, 5.36 Fahrenheit and 7.70 Fahrenheit. And as you can see, we had two different clusters running. So we have two different temperatures, but of course you can just find the minimum of these two. And that would be pretty much it. Okay, and I believe we have time, so we can do another example. This one we're going to be just finding the word count. So, for different counts of a book, we're just going to be finding the number of words, the number of times that word is displayed. So, let's call this input. And that equals SC, which is the Spark content dot text file. So we're going to be doing this again. And we're going to call this book dot txt, right? Because book is the name of the file that we have. And what we're going to be doing here is, each line or each paragraph, we're then going to be flattening it out. So word equals input dot flat map. And the difference between what map and what flat map does is, map will, if your data set, if what you were mapping has just one value or an X amount of values, the answer will return X amount of values as far as the columns for what you were mapping. In our case, we saw it when we were mapping previously up here. Yes, we were mapping. You see, we have the lambda x. So for each x, it can only return one thing, which is this key value pair. So it's only returning one thing for each x. But for flat map, we can return multiple values. So that's one of the functions difference between map and flat map. So we have lambda x, such that we're just going to be splitting the string. So, of course, the string split's going to give you multiple different things, different values. We're going to split the string by the space and give values for each thing that was split in the space. So we have then input flat map. And then after we have the flat map, we're going to count the word by value. Word counts equals words dot count by value. And the count by value is an action as well. So now it's going to be taking action. Going to be word is not defined because I like to add S's. And so now, it's using the map reduce to then map exactly the best way in order to get all of these stages completed in the best fashion. And you can see now it's finished. And let's write a little function for the word and the count in word counts dot items. So it returns the items. And what we're going to be doing is we're going to so the word, if the book.txt file did not have the words correct or was not properly encoded, then we're going to properly encode it in ASCII format. So word.encode and ASCII format, and going to ignore the ones that cannot be encoded. And other thing we're going to do is we're going to call a couple of functions. So if it is clean word, so that's going to return a true or false, whether it's ASCII or false if you have to ignore it. So if it's clean word, and also if the count is, let's say, greater than 25, what I'm going to do is I'm going to print clean word dot, and so decode what the word is, and then plus, and then put a tab there, and then the string, and you want the word count. So yes, it seems so. Word count is not defined because I forgot to put the S in this time. Okay, so word counts. And of course, we could have just put an statement instead of just doing two if statements. Bad Python skills that I'm doing right here, but print. So all the words that are represented more than, what was it, 25 times or 50 times? 25 times. So we have a list of all of the, so it's printed out all the words that represented more than 50 times. Okay. And that is it as far as the example in Spark. I will stop sharing my screen. And so Spark, just like Hive, can, well, we're going to be going over Hive later, but, using the MapReduce, parallelizing instead of, having a bigger data set, or a bigger memory on one computer and having multiple different computers, that can work much to an advantage, especially when you're dealing with big data. So if there are any questions, let me know. I will be here for the next 5 minutes. I'll also provide different materials for commands that will be used a lot for Hadoop and commands that are used a lot for Spark as well. So just provide different materials on that. That's the great functionality about Spark, is that you want to keep using these commands, these filters, these map commands as much as possible, keeping it within that system, letting um, the MapReduce algorithms chart the best path, and then only when you need the data, uh, collect the data, or count or use an action term to then take the data out of the um, algorithms, and then from there proceed on to just proceed on from there. So that is a taste of Spark. Spark can be used in Python, Scala, Java. Very, very useful when you are analyzing big data. Also, there are ways which you can, have Spark on your own PC. So most PCs that are out now are, they have multiple cores in the PC. My PC has four cores. So there's a way to program the PC. I have my program previously. I have my PC previously programmed to do it, but you can program the PC in order to use the four cores in order to complete the tasks that are necessary with Spark. So you can use Spark on a PC as well. It will allocate uh, and distribute the files and use the algorithms the same way which you would see on the cluster. And I did put a Hadoop Hive in Spark. We now have time to do Hive. So next week we will do a couple of Hive examples. So it'll be Hadoop Hive Spark Part 2. But this is just it's just a quick couple of examples. You have a lot more commands that you can do in Spark, a lot more actions you can do in order to get what you want from the uh, uh, data. So this is just a small example. Of course, if you need any of this, I'll provide some references and some documents. But of course, doing your own research and learning about it yourself. This is a quick just tutorial, our tutorial. Okay, well, the tutorial is concluded. Webinar is concluded. Thank you for watching, and peace.